Hi everyone, this lesson is on proving lines parallel. So let's get started. Let's get started with a warm-up solving for variables. So what we have here are two parallel lines, and we are cut by transversal here, cut by transversal here. In addition, we know that if this angle here is 90 degrees, then this angle up here is also 90 degrees. And therefore, if that's 90 degrees, we can say that z plus 10 plus 40 is equal to 90 degrees. Then we have z plus 50 is equal to 90. So we have z equals 40 degrees. And so z is 40. Okay, let's move that up. All right. So if z is 40, 40 plus 10 is 50, so this is 50 degrees right here. We know that if that's 50 degrees, this is 50 degrees too, because you have this transversal right here. And so therefore, y is also 50 degrees. So there's 50. To find x is right here. So to find x, what you would do, you have a couple of options. You know that 50 plus 2x is equal to 180 because those are same side interior angles and they're supplementary. So you can actually say 50 plus 2x is equal to 180 degrees. You could have also said this plus this, 2x plus 50 is 180 degrees because that makes a line. Anyway, subtracting 50, we get 2x is equal to 130 degrees. X equals 65 degrees, so there's 65. For this problem right here, what you have is you have three parallel lines, three lines that are parallel to each other. Therefore, this angle right here and this angle right here, we call those alternate interior angles because they're inside the parallel lines. So one of your equations is x plus y is equal to 60. And then you have another set of parallel lines right here, these two, this one and this one. So that's parallel to that. And then therefore you have another set of alternate interior angles. So then you can also say x minus y is equal to 46. Now you have two equations and you have two unknowns. And we call that a system of equations, which you most likely learned back in algebra. And what ends up happening is you can add them, subtract them, multiply. There's a couple of different ways to solve them. Cramer's rule, augmented matrices. Anyways, just for this one, we just add them. You get 2x. Y's cancel. So you have 2x is equal to 106. And if I divide by 2, I'm going to get x is equal to 53. So once you find that value and you have x is equal to 53, you should plug it back in. So what I'm plugging it into this equation right here. And so what I have is 53 plus y is equal to 60. So if I subtract 53 from both sides, I get y is equal to 7. For the next problem right here, this chapter, this section is all about proving lines are parallel. And what information is enough to decide that two lines are parallel? There's actually 5 ways to prove that two lines are parallel. So showing those 5 ways of two lines are parallel, try to come up with those ideas on your own. So if you wanted to pause the video for a few minutes and try to come up with the 5 ways to prove lines are parallel, that's okay. So the first way to prove that lines are parallel would be to prove that the alternate interior angles are congruent, meaning I could have this line here and I could prove that this angle is congruent to this angle here, and that's my first way. My second way would be to prove that corresponding angles are congruent. So I can prove that corresponding angles are congruent. And what that would look like on this graph would be your transversal. You could prove that this angle is congruent to this angle. You could prove this angle here is congruent to this angle, and then their counters also. Number 3, another way to prove that two parallel lines or two lines are parallel would be to prove that the same side interior angles are supplementary. And if you did that, then that would be looking something like this. You could show that you have a transversal. You should show that this angle here plus this angle here would add up to be 180 degrees. The fourth way to prove that two lines are parallel would be to show that two lines are parallel to a third line. And what that would look like would be something like this, where we already know that this line is parallel to this line. Well, if I had another line, and I know that this line is parallel to this line, and I could show that this line here is parallel to this line here, then I would say that this line on top is parallel to this line on the bottom. The fifth way to prove two lines are parallel is to show that two lines perpendicular to the same line are perpendicular to each other, or form parallel lines. So say form parallel lines. And so what that would look like is this. If you were to have two lines perpendicular to the same line, this one and this one, that would mean that these two lines would have to be parallel. And so those are the 5 ways that you would use, that you would prove two lines are parallel. So delving into that perpendicular to parallel lines theorem, that's a theorem you would use that for a proof. In a plane, two lines are perpendicular to the same, two lines perpendicular to the same line are parallel. Number 2, the 3 parallel lines theorem. Two lines parallel to a third line are parallel to each other. Again, this is parallel to this. This is parallel to this, which makes this top one parallel to the bottom. And that would be by the transitive property also. Corresponding angle postulate, that basically says if I have two angles that are congruent, because you have to remember that lines can be corresponding. For example, I could have this angle up here and I could have this angle down here, but they're not congruent. The only reason those corresponding angles would be congruent is if I knew that these lines were parallel. Or if I proved that these two angles are congruent, that would form parallel lines. So basically, the point is that you can have corresponding angles, but they don't have to be parallel. But if you do have congruent corresponding angles, then the lines have to be parallel. If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Okay. The converse of the alternate interior angle theorem, that basically said if you have two lines that are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Converse of the same side interior angles theorem, if you have two lines cut by a transversal, there's your transversal, and you have these two angles right here, they're not congruent, but their sum adds up to be 180 degrees. Therefore, if the same side interior angles are supplementary, then the lines are parallel, meaning this line is parallel to that line. And sketching a picture in a plane, two lines perpendicular to the same line. So basically, you have two lines perpendicular to the same line. You have this looks like this. That would be perpendicular to that. That would make these two lines parallel. Same lines are parallel. Two lines parallel to the third line. Same thing. You have two lines. These are parallel to each other. You have a third line. And you have this line parallel to this line. That makes this line on top parallel to this line on bottom. So they are parallel to each other. So that's another theorem. In the first theorem, though, it said in a plane, And that's really important because you need to realize that parallel lines have to actually be in a plane to be parallel. All lines are parallel, but they have to be in a plane. If they're not in the same plane, they could be skew. So the question is, if you have three lines, and if the three lines are not all in one plane, is it possible for two lines to be perpendicular to the same line, but not be parallel to each other? So if you try to sketch that, what you would get would be something like this. And if you did get this, let's see, notice that we do have these two lines parallel to each other, but I could have a perpendicular line here, and this is not in the same plane, therefore it would be skew. But if the three lines are not all in one plane, it is possible for two lines to be perpendicular to the same line, but they're not parallel to each other. Okay, now this is the converse of the theorem. So the original theorem that we did last section was if two parallel lines are cut by a transversal. So we have two parallel lines, we have a transversal, they're cut. Then the corresponding angles, which could be this one and this one, could be this one and this one, there's four different types. Those are congruent. The converse basically flips them around and says if you have two lines cut by a transversal and the corresponding angles are congruent, then you would know that the lines are parallel. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. That means that angle would be congruent to that angle. The converse is two lines are cut by a transversal and the alternate interior angles are congruent, then you would say the lines are parallel. If two parallel lines are cut by a transversal and the same side interior angles are supplementary, what that's saying is this angle here and this angle inside, or the other side, their sum adds up to be 180. If two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So again, the 5 ways to show that a pair of corresponding, you would show that the 5 ways to prove two lines are parallel is to show that a pair of corresponding angles are congruent, alternate interior angles are congruent, show that a pair of same side interior angles are supplementary, or in a plane, show that both lines are perpendicular to the third line, show that both lines are parallel to the third line. So what we have is a proof, and given this proof, what you're looking at basically is you're trying to prove the theorem. The theorem is that if two lines are cut by a transversal and the alternate interior angles are congruent, so you're proving the converse of the theorem, then the lines are parallel. So what you're given is that the alternate interior angles are congruent. So you're given that angle 1 is congruent to angle 2. That's what you're given. This angle here is congruent to this angle here. You're also trying to prove that the lines are parallel. So you're trying to prove that L is parallel to N. So within your statements, you're given is that 1 is congruent to 2, and that's your given. Now looking at this picture, in addition to that, you also know that angle 3 is congruent to angle 1 because those angles are vertical angles. So you could say that angle 1 is congruent to angle 3 because they are vertical angles. In addition to that, what you should be noticing is this, is that you've got 1 congruent to 2 and you've got 1 congruent to 3. So what you're looking at is these two angles right here. See how those are the same? Angle 1 is going to equal 1, which means that angle 2 must equal angle 3. And so what you're doing there is you're saying angle 2 is equal to angle 3. And that's because of the transitive property. You're saying 1 is equal to 2, 1 is equal to 3, so we know 2 is equal to 3. And lastly, you prove that L is parallel to N because if you look at these and you see that 2 is congruent to 3, see how these angles are up here and this one here? Well, those are corresponding angles. So if we, and that's one of the 5 that we can use to prove that lines are parallel. So therefore, if 3 is congruent to 2, those are corresponding angles, therefore they're parallel. For this problem right here, you would need to solve for x. Those are degree signs, by the way. We know we're trying to find the value of x that makes the lines parallel. So I would need to find a value that would work to make these equal to 180 degrees. So I would start off with saying x squared plus 3x is equal to 180 degrees. Now, one thing is what you need to notice is that this is a quadratic. And therefore, if this is a quadratic, then your first step always is to set it equal to 0. So you have x squared plus 3x, move the 180 over, so minus 180, and that equals 0. At this point, there's 2 ways to solve this. You can use the quadratic formula, or you can try to factor. I'm going to try to factor, and in factoring, we know that x times x is x squared. For this problem right here, we need to figure out for this is a minus, so we know that's a positive times a negative. What we don't know is what our values of 180 are going to be. So on the side here, I'm going to choose to try to come up with values for 180. So I know that 1 times 180 is 180, but that's not going to add up to 3. I know that, let's see, 2 times 90 is 180, but that's also not going to add up to 3. I know that 3 times 60 is 180, and that's not going to add up to 3. So at this point, I'm just going to go from here, and I'm going to say, well, what are the factors here? And let's see, what are the factors of 60? So if I broke this down, I see that's 6 times 10. And breaking that down, that's 2 times 3. Breaking that down, that's 2 times 5. And so what I have is 3, 2, I have 3, I have 2, and I have 5. So these are all the factors of 180. So what I need to do is to come up with a number that's going to be added up to, that's going to add up to be 3. So I'm going to try different variations. So I'm going to say 3 times 2 is 6, 6 times 3 is 18, times 5 times 2, 10. Okay, well, that's still not adding up to 3. So let's try a different one. Let's see, 5 times 3 is 15. And then what's left is 3 times 2 is 6. 6 times 2 is 12. So I have 15 times 12. And that is actually going to add up to be 3. And it's a positive 3. So my higher number 15 is going to be plus. This is going to be 12. I'm going to split this up, and I'm going to set both of these equal to 0. So x minus 12 is 0. So x equals 12. I have x plus 15 equals 0, so x equals negative 15. So both of these answers actually aren't going to work, because if I were to plug in 15 back into this equation, that would be 3 times negative 15, which is negative 45 degrees, and that you can't have a negative degree there. So 15 is out. So let's try and just check 12. If we were to check 12, 3 times 12 is 36, so that would be here. And this would be 12 times 12, which is 144. And 144 plus 36 actually adds up to be 180, which is what we needed for this value to prove that the lines are parallel. So therefore, x equals 12, which is our answer. So moving to angles of a triangle, classifying the angles by the sides. An equilateral triangle is a triangle that has all 3 sides congruent. So you would say 3 sides congruent. An isosceles triangle is where you have 2 sides congruent. So 2 sides congruent. A scalene triangle is all sides are not congruent. So none of these sides are the same. So you have 3 different values for the sides. Each one is different. no congruent sides. For an acute angle or acute triangle, an acute triangle basically has three angles that are less than 90 degrees. For a right triangle, you have one angle that is right. For an obtuse triangle, you have one angle that is greater than 90 degrees. And for an equiangular triangle, what that means is you have three angles that are congruent. Now, so three angles congruent. So what you need to know about this is that if you have an angle, let's say, let me just draw this angle here, and that angle is congruent to these other angles. The side opposite that angle, so let's draw on that side. That angle right there, the side opposite, is congruent to the other angle that's the same length or the same measure. So these two lengths are the same. Likewise, if my sides are equal, then the angles opposite those are congruent. So if this side is equal to that side, then these two angles are congruent. If this side is equal to this side, then this angle is congruent. So keep in mind also isosceles triangles. We know this side is congruent to this side, therefore the angles opposite those sides that are congruent are also congruent. A triangle sum theorem actually is very important. The sum of the measures of the angles of a triangle is 180 degrees. That means that if you add up y plus x plus z, you're going to add that sum is going to equal 180 degrees. Now, what we have here is three angles, and we know we just talked about their sum, this angle plus this angle plus this angle, the sum is equal to 180 degrees. So I could say 2x plus x plus 28, and that adds up to be 180 degrees. So 2, 3, 4x. So I've got 4x plus 28 is equal to 180 degrees. So we have 4x is equal to 180 minus 28. So we're going to subtract 28 from both sides, and you get 8, 7, 1, 52. And then we're going to divide both sides by 4, and we're going to get x is equal to 4 goes into 15 3 times. That's 12, 13, 14, 15. 3 left over. 4 goes into 32 8 times. So I have x equals 38. One thing that I would just caution you is just to really read the question, because even though we got x and we're super happy that we got x, the question may not be find x. The question might be find the largest angle. So if that was the case, to find the largest angle, you would need to plug 38 back into this equation just to make sure, well, which one's going to be the larger? This is 38, okay? This one is 38 times 2, okay, 16, carry the 1. So that's 76 right here. So this is 76. And then this angle right here is 38 plus 28. And so that angle right there would be, what, 16, 3, 4, 5, 66. So the largest angle would be 76 degrees. So just be on the lookout for what they're actually asking, because you do need to find x. But once you find x, you need to know what to do with that value. So in auxiliary line, we talked about this the other day. We actually used an equation that might have been something similar to this, where we had two parallel lines, and then we had this odd shape. And we had to find all these values in here. And one of the things is that an auxiliary line is a line or ray or segment that you add to a diagram to help you solve it. And so I could add an auxiliary line in like this. And this auxiliary line would need to be parallel. And what that benefit for that would be is that now I have alternate interior angles. Now I have same side interior angles. So that has a lot of benefits to it. In addition to that, I could also draw in an auxiliary line that's, let's say, perpendicular. And the benefits of that would be that I could take this perpendicular line and I can move it. And maybe that would be nice right here or right here. So that, if it's perpendicular, it also is very helpful. Okay, so that's an auxiliary line. Again, it's just a line that you draw into your diagram to help you prove it. So just classifying triangles by their sides, we have an equilateral triangle. If you recall, equilateral means all sides are congruent. We have isosceles, which means two sides are congruent. Scalene means all three sides are not congruent. An acute triangle, remember, only has one acute angle in it, or excuse me, an acute triangle only has all acute angles. A right triangle has only one right angle. An obtuse angle has one obtuse angle in it, and equilateral has three equal angles. Now, this is what we call a paragraph proof. Now, a paragraph proof is used similar to a two-column proof, but this is called a paragraph proof because we're proving what we want to say in a paragraph form. So what we're trying, given that we have triangle ABC, which is right here, we're trying to prove that angle 1 plus angle 2 plus angle 3, so this angle here, and this angle here, all add up to be 180 degrees. So for us to be able to do that, okay, we drew in this auxiliary line right here. So through point B, draw line BD such that it is what to AC. So this auxiliary line does need to be parallel to AC. By the linear pair theorem, which basically means you have two angles that form a line, you have DBC, so we have DBC, so DBC, so this angle, this big angle right here, plus angle 5, which is right here, that adds up to be 180 degrees. By the angle addition postulate, you also know that DBC, just this angle right here, adds up, or what that is equal to is angle 4 plus angle 2. By substitution, and of course you're substituting DBC, okay? You're plugging in 4 and 2 right into here. You know that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. Looking at parallel lines, so if I'm looking at parallel lines, which are these two parallel lines, since DB is parallel to AC, when lines are parallel, their alternate interior angles are congruent. So now I'm looking at what's angle 4 congruent to? Well, 4 is congruent to 1, so we can say the measure of angle 1. We also know that angle 5 is congruent to angle 3, measure of angle 3. And therefore, if you go back up to this statement right here, okay, if you look at this statement, which says 4 plus 2 plus 5, see, 4 plus 2 plus 5 is add up to be 180. And you replace 4 with 1, and you replace, so I'm going to swap out these two angles right here, and you're going to replace 3 with 5 because those are equal. You're going to end up getting the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And because you're swapping these out, we call it the substitution property of equality. Substitution property of equality. So this right here has to do with the triangle exterior angle theorem. And this is actually very important. You're going to see this on a lot of your exams that you're going to see in your future, like your SATs and stuff like that. What this says is the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior of the triangle. So just a little bit of geography here. 1 is outside of this triangle, so we call that exterior. So that angle is your exterior angle. You know that 3 and 2 and whatever this angle is, those are all interior. But the big important word is that it's remote. Remote means away from, far away from, remote. So therefore, a remote angle cannot be right here. It needs to be away from there. So what this theorem is saying is that the measure of angle 1, which is my exterior angle, is equal to the sum of the remote interior angles. So that means the measure of angle 3 plus the measure of angle 2. So that's what that says. In addition to that, we have a few more theorems that need to be, and corollaries that need to be discussed. One of them states that if I have a triangle and I have two angles that are congruent in one triangle, and then I have two angles are congruent in this triangle. So this angle here is congruent to this angle here. A is congruent to angle Z. So if I already have two angles in two different triangles that are congruent to each other, then the third angle, which is going to be angle C, is going to be congruent to angle Y. Meaning this angle, whatever this is going to be congruent to this. In addition to that, another corollary says that each angle of an equilateral triangle has a measure of 60 degrees. Because if you have a triangle that has three sides congruent, then all the angles opposite those sides have to be congruent as well. And if you take the sum of the angles of a triangle, which is 180 degrees, and you divide that by 3, you're going to get 60. So you have 60 degrees for each of your angles. This another corollary, number 3, in a triangle, there can be at least only one right triangle and a right angle in a right triangle, and only one obtuse angle in an obtuse triangle. And in addition to that, something that not a lot of people think about, because they think, well, if I'm going to add up the angles of a triangle, then I know that the measure of angle 1 plus the measure of angle 2 plus this value, which is 90 degrees, is equal to 180 degrees. Well, if you were to subtract 90 from both sides, you would get the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. And in that case, what you're basically saying is these two, if you have a right triangle, it has to be a right angle, that right there, then the remaining two angles are complementary, which means their sum is going to be 90 degrees. So based on this information for this next slide, we know that, or which lines, if any, can you conclude to be parallel if, let's start off with angle 1 congruent to angle 8, okay? So if 1 was congruent to 8, actually, that would mean that this line right here would have to be parallel to this line right here. Because what that does is that gives us this line as a transversal. And so therefore, you would say, where's my pen? There it is. Therefore, you would say that, which ones would be parallel? That would be J. J is parallel to K. Okay, let's erase that. In the next problem, it says 3 plus 4, so we have this plus this is equal to 180. That means those are same side interior. Well, those are same side interior because what you have is this line right here parallel to this line right here. Okay, and so if that's the case, then what you have is, let's see, this is my transversal right here, which is L. So therefore, again, J is parallel to K. Okay, for the next one, you have 10 and 10's congruent to 7. So this angle here and this angle here are congruent. So you have this line being your transversal and this parallel to this also, okay? So therefore, we know also that J is parallel to K. Now, this one is a little bit different because this one is saying that 6 and 7 are supplementary, meaning this one plus this one equals 180 degrees. Well, for that to happen, you would actually need this line parallel to this line. So you would actually need to say that L for this problem is parallel to N. And lastly, for 6 to equal 7, for these two values to be equal, if they're on the same side interior, the only way that these two angles can be congruent, because they have to be 180 degrees, so the only way that they would be congruent is if they were perpendicular. So you would have to say that L is perpendicular to N. For this problem, you need to find the value of x that makes J parallel to K. Well, if this angle was congruent to this angle, they would be alternate interior angles, and therefore that would make this line parallel to that line. So let's see if we have 3x plus 10 is equal to 5x minus 10, because that would make them congruent. And so you have 3x, or subtract 3x, I have 2x here. And if I add 10 to this side, I'm going to get 2x equals 20. And therefore, x is equal to 10. So the value of x that would make these two lines parallel would be if these were congruent, and that would be x is 10. Likewise, this angle here plus this angle here would have to add up to be 180 degrees for these two lines to be parallel. So you would have 6x plus 5x plus 15 equal to 180. So I have 11x plus 15 is equal to 180. So I have 11x is equal to 180. Oh, I need to subtract 15 from both sides. There we go. Let me erase that. Okay, so what I have here is 11x is equal to, subtracts, we have 5, 8, 7, bring down 1, 6, and then we have 165. And so what you would do is you would take 165 and you would divide by 11, and that is, I believe it's 15. And so you'd have x is equal to 165 divided by 11, and that should be 15. And so therefore x is equal to 15. For this problem, to show that these are parallel, you would say that's right. This is right, and this is right, which would make that right, and that right, which would make actually this angle here equal to this angle, which is basically an alternate interior angle. So we can say that 2x minus 10 is equal to 90 degrees, 2x is equal to 100, and x is equal to 50. And therefore, these two lines are parallel. For this one, these are, again, same side interior angles. So I would say 3x plus 8 plus 7x minus 8 adds up to be 180 degrees. 10x, my 8s are going to cancel. 10x equals 180 degrees. I'm going to divide both sides by 10. I get x is equal to 18 divided by 1, which is just 18. So I hope that helped. Thanks for watching.